In the previous video, I have explained to you about Lyman, Balmer, Paxton and these kind of series. Now, this is one wavelength, another wavelength, another wavelength. In between these two, there won't be any wavelength. Okay, so either it is from 2 to 1 that associated with one wavelength. For example, 4000 angstrom. I'll take Balmer series because 4000 angstrom comes in visible spectra. Now, if this is 4000 angstrom, then the next one will be, let's say, 5000 angstrom. In between that, there are no other wavelengths. So, for example, if you are seeing violet, then indigo may be missing. The next will be blue. Then green may be missing. Then next will be yellow. So, how will be the spectral line? We have a dark band here. So, this is emission spectrum, right? As of now, it is heated. Now, this is emitting, right? Emitting radiation. So, output as of now, it should be dark because we are not expecting any kind of de-excitation here. We have a dark band. Now we are seeing the emitted radiations here. So, we are going to get a white band here. That is one color. And after that, there are no other bands receiving. Now, let's say this is violet, indigo, blue, green are not there. Then we are able to see yellow. Then orange is missing, red we are able to see. So, these are bright bands. Okay. So, this is dark and this one is dark and this one is dark. So, we are able to see violet, then green, then red. This is just for example. So, in a dark band, we will be able to see these colors, only violet, green, red. Other colors are not emitted because we don't have, such kind of energy transition. So, this is emission spectra. Now, what was the absorption spectra? The same specimen. Now, forget everything about de-excitation. We have a de-excited specimen here. There are no excited electrons. There are no excited atoms. Now we are allowing the white light to pass. So we are expecting a white color band outside. But in that, violet is missing and green is missing and red is missing. So what is this? This is absorption spectra. From white, these many colors are absorbed, only remaining is given out. Now, in this case, from excited state, we are getting only certain bright bands, others are still dark. Now, see, whichever has shown here, that is missing here. Whichever has shown here, that is missing here. Green has shown here, that is missing here. Red has shown here, that is missing here. What is the reason? Now, whenever a specimen, a container, gas inside a container excite, this will take violet radiations and green radiations and red radiations. Now it is excited state. Now from the excited state, it is coming back to the ground state that are emitted. So these colors are taken inside and that has gone to an excited state. Now when we are allowing the emission spectra to happen, now the excited gas is giving out the energy while coming into ground state, the same colors will be given out. Okay, so this means that it's the same energy transition when it goes from 1 to 2. So let's say from 1 to 2, if from 1 to 2, it needs energy, right? Lower energy, higher energy. So from 1 to 2, if it is taking violet color, now at some position, if it de-excites from 2 to 1, it will be the same energy, same color of radiation given out because the energy difference is same. 1 to 2 if you are taking in this way or 2 to 1 if you are taking in this way. So same energy difference. Only the difference here is from 1 to 2 absorbing, from 2 to 1 emitting.